Hi students, welcome to Sankalp Learning Classes. In this session, we'll be dealing with the 3 mark questions of the chapter Inverse Trigonometric Functions. So without any delay, we'll move on to our first question. Okay. So the first question is, solve for x sine inverse of 1 minus x minus 2 sine inverse of x is equal to pi by 2. Okay. The first question is, we have to find out the value of x such that it satisfies the equation sine inverse of 1 minus x minus 2 sine inverse x is equal to pi by 2. All right. So here, this one is true, right? Sine inverse of 1 minus x minus 2 sine inverse x, that is equal to pi by 2. It is given in the question. Okay. So I'm taking this 2 sine inverse x to the other side. All right. So this will become sine inverse of 1 minus x is equal to pi by 2 plus 2 sine inverse x. Okay. What we are going to do is that we have to find out the value, that is, you have to solve for x, right? So now I'm taking the sine inverse to the other side. So what will be it? That is 1 minus x equal to 1 minus x equal to the sine inverse when you are taking to the other side. If sine inverse x is equal to y, if sine inverse x equal to y, we can write this x as sine y. X can be written as sine y, right? So this, if I take sine inverse to the other side, it will become sine of, right? Sine of pi by 2 plus 2 sine inverse x. Pi by 2 plus 2 sine inverse x. Now, if you observe this format, okay, if you observe that format, it is of the form sine of pi by 2 plus theta. Isn't it? It is of the form sine of pi by 2 plus theta. And what is sine of pi by 2 plus theta? It is cos theta. Isn't it? How will you understand it with the help of a quadrants? That is sine of pi by 2 plus theta. This is pi by 2. Pi by 2 plus theta means here, right? Which means that is in the second quadrant, and in the second quadrant, sine is positive, right? So here it is sine. So the answer will also be positive. So positive. And since it is pi by 2, if pi by 2 or its multiples, multiple of pi by 2, that is 3 pi by 2, 5 pi by 2, all that come, we know that if here it is sine, then its co-function will come in the answer, right? What is the co-function of sine? It is cos. So positive cos theta. That's how you got this answer. Sine of pi by 2 plus theta is cos theta. Okay, so this can be written as sine of pi by 2 plus 2 sine inverse x. Here in place of theta, it is 2 sine inverse x. So what will be the answer? It is nothing but cos of 2 sine inverse x, right? Cos of 2 sine inverse x. What is this? 1 minus x. 1 minus x is equal to cos of 2 sine inverse x. And we need the value of x. So I am taking that x to the other side and this cos 2 sine inverse x to the left side. So what happens? 1 minus cos 2 sine inverse x is equal to 1 minus cos 2 sine inverse x is equal to x. If I take minus x to the other side, it will become plus x, right? So it is equal to x. Okay. Again, now we want to apply another identity, that is 1 minus, the identity 1 minus cos 2 theta is equal to, what is 1 minus? 1 minus cos 2 theta. 1 minus cos 2 theta is nothing but 2 sine square theta. Isn't it? 1 minus cos 2 theta is 2 sine square theta. Here you can see that it is in the same format. 1 minus cos 2 sine inverse x. That is, in place of theta, it is sine inverse x. Okay, in place of theta, it is sine inverse x. So how can you rewrite this one in terms of sine? You can write this one as 2 sine square. 2 sine square, in place of theta, it is sine inverse x, right? So 2 sine square of sine inverse x. 2 sine square of sine inverse x, that is equal to x. Okay, now, okay, so 2 sine square of sine inverse x is equal to x, isn't it? Now, the sine square of sine inverse x can be written as 2 into sine of sine inverse x the whole square, isn't it? Sine square x can be written as sine x the whole square. Here, in place of x, it is sine inverse of x. Okay, so it can be written as 2 sine into sine inverse of x the whole square. That is equal to x. And we know the property sine of sine inverse x. Sine of sine inverse x is nothing but x, right? So this can be rewritten as 2 into x the whole square equal to x. Okay, is equal to x. Now, this can be written as 2x square. If I take this x to the side, left side, 2x square minus x equal to 0. Isn't it? So, if I take x common from this, you'll get x into 2x minus 1 equal to 0. Which means either x can be 0 or 2x minus 1 can be 0. Either x can be 0 or 2x minus 1 can be 0. From this, you get 2x equal to 1, x equal to 1 by 2. So x has two options. We got two options for x. What are they? Either x can be 0 or x can be 1 by 2. Now we have to check which of the x from this satisfies the equation that is given in the question. Alright, so first of all, I'll start with x equal to 1 by 2. Okay, that is, you check whether x equal to 1 by 2 satisfies the equation given. What was the equation? It is sine inverse of 1 minus x minus 2 sine inverse x equal to pi by 2. This was our equation. You check whether x equal to 1 by 2 satisfies this particular equation. Okay, for that I am substituting 1 by 2 in place of x. That is 1 minus 1 by 2 minus 2 sine inverse of 1 by 2, that is equal to pi by 2, right? So we have to get this one as pi by 2. So by solving, when you put 1 by 2, you have to get pi by 2 if it is if x equal to 1 by 2 satisfies that equation. All right, so this will become sine inverse of sine inverse of 1 minus 1 by 2 is 1 by 2 minus 2 sine inverse of 1 by 2. All right, what is this 1 by 2? 1 by 2 can be written as sine inverse of sine pi by 6. Sine 30 is 1 by 2. So this can be written like this, right? So that is equal to minus 2 sine inverse of, again 1 by 2 can be written as pi by 6. So the sine inverse of sine pi by 6 will become pi by 6, and we know that pi by 6 belongs to the PVB of sine inverse, right? So this minus 2 into pi by 6, that is equal to minus pi by 6, right? Minus pi by 6. So on solving the equation with x equal to 1 by 2, we got the answer as minus pi by 6. Okay, we got the answer as minus pi by 6. So, can you say that x equal to 1 by 2 satisfies that particular equation? No. X equal to 1 by 2 does not satisfy that particular equation. Now we check with x equal to 0. Alright, we are going to check x equal to 0, whether it satisfies the equation or not. So consider x equal to 0. Alright, 1 minute. Okay, so let's check whether x equal to 0 satisfies that particular equation. Alright, so again consider the equation, that is sine inverse of sine inverse of 1 minus x minus 2 sine inverse x. Okay, so this is our equation and I'm going to put x equal to 0. Sine inverse of 1 minus 0 minus 2 sine inverse 0. Okay, so that is equal to sine inverse of 1 minus 2 sine inverse of 0. Okay, so this is equal to pi by 2 and we know 0 sine 0 is 0, right? So this will become minus 2 into 0. Right? Sine inverse of 0 is 0 because sine 0 is 0, right? So sine inverse of 1 minus 2 sine inverse of 0 will become pi by 2 minus 2 into 0. Sine inverse of 1 can be written as pi by 2i because the value of sine pi by 2 is 1. So if you want, I can write one more step here. That is, here sine inverse of 1 can be written as sine pi by 2, then minus 2 sine inverse of sine 0. Sine 0 is 0, right? So again, if you apply the property sine inverse of x, sine x is equal to x, we'll get this answer as pi by 2 and we know that pi by 2 belongs to the principal value branch, right? Minus, then here it will be 2 into sine inverse of sine x is equal to x, so it will be 0. So the answer is pi by 2. So this was our RHS, right? This was our RHS of the equation, right? So we got the RHS, which means x equal to 0. This implies that x equal to 0 satisfies x equal to 0 satisfies the given equation. Satisfies the given equation. So x equal to 0 is the answer. All right. Now we are moving on to the next question. That is the second one. You have to write the simplest form, right, or find the simplest form of tan inverse of cos x by 1 minus sin x minus 3 pi by 2 less than x less than pi by 2 in the simplest form. Okay, so this is our second question. We have to write the simplest form of tan inverse of cos x by 1 minus sin x. So how will you write the simplest form? We have to use 7 trigonometric identities and solve it and reach to a simplest form of this one. All right. So here this cos x can be written as, we have to apply the identity. Cos 2x can be written as cos square x minus sin square x, right? Cos 2x can be written as cos square x minus sin square x. So what about cos x? Cos 2x is this. Then what about cos x? Cos x is equal to cos square x by 2 minus sin square x by 2. Cos x is nothing but cos square x by 2 minus sin square x by 2. So numerator can be written as cos square x by 2 minus sin square x by 2. Cos square x by 2 minus sin square x by 2. Alright, divided by. Now, 1 can be written as, okay, I'm going to write this 1 as cos square x by 2 plus sin square x by 2. Why am I writing like this? Because we know the identity cos square x plus sin square x is equal to 1. Right? Here, since the numerator is in the angle x by 2, since we have taken the numerator as x by 2, so I am taking the denominator as also as x by 2 in order to make the adjustment because we need the simplest form, right? So that I am using the identity, the same identity, but I'm taking the half angle. Okay, I'm using the same identity, but I'm taking the half angle. So 1 can be written as cos square x by 2 plus sin square x by 2. Okay. Cos square x by 2 plus sin square x by 2. That is also 1. Now, what about the sin x? Sin x should also be converted into such a form. So we know the formula. Sin x is equal to sin 2x is equal to 2 sin x cos x, right? Sin 2x is equal to, so it is again another identity. 2 sin x, sorry, 2 sin x cos x. Okay. This can be written as sin 2x. Okay. So sin 2x is 2 sin x cos x. So what about sin x? From this you get sin x, right? You take, this is sin 2x. When it is 2x, half of the angle comes here. So when it is x, half of the angle is x by 2. So this can be written as 2 sin x by 2 cos x by 2. Isn't it? Sin x can be written as 2 sin x by 2 cos x by 2. So I am substituting here 2 sin x by 2 cos x by 2. Okay. Now we know that the numerator is of the form a square minus b square, right? Cos square x by 2 minus sin square x by 2 means it is of the form a square minus b square. That is equal to a plus b into a minus b. A plus b into a minus b. So this can be written as cos x by 2 plus sin x by 2 a plus b. Here a is cos x by 2 and b is sin x by 2. So a plus b into a minus b cos x by 2 minus sin x by 2. Cos x by 2 minus sin x by 2 divided by Hmm? The new denominator is of the form a square plus b square minus 2ab. A square plus b square minus 2ab, which means it is of the form a minus b the whole square, right? A minus b the whole square. A is cos x by 2 and b is sin x by 2. So this can be written as a minus b the whole square. So that is cos x by 2 minus sin x by 2, a minus b the whole square. Okay, a minus b the whole square. Now I'm going to cancel this one a minus b. This can be a minus b the whole square can be written as cos x minus x by 2 minus sin x by 2 into cos x by 2 minus sin x by 2. So there will be 2 cos x by 2 minus sin x by 2, right? So we can cancel it with the numerator. Here also you can see a cos x by 2 minus sin x by 2. So I am cancelling this one with one of the denominator. All right. So what is remaining here? What is remaining? That is, I have converted this into, the first one is a plus b into a minus b, right? So I'm writing it again. This a plus b into a minus b cos x by 2 minus sin x by 2. And the denominator can be written as a minus b the whole square form, right? So that is cos x by 2 minus sin x by 2. A minus b whole square can be written as a minus b into a minus b. So cos x by 2 minus sin x by 2, right? And we can cancel these because common in numerator and denominator. So this will become tan inverse of cos x by 2 plus sin x by 2 divided by cos x by 2 minus sin x by 2. We are going to divide throughout by cos x by 2. That is, for each term you divide it by cos x by 2. So this will be tan inverse of cos x by 2 plus sin x by 2. Okay, each term you are dividing with cos x by 2. In the denominator also you divide with cos x by 2. Okay. Now, what about cos x by 2 divided by cos x by 2? It is 1, right? So this will become tan inverse of 1 plus What is sin x by 2 divided by cos x by 2? Sin by cos is nothing but tan. So it will be tan x by 2 divided by, again, the denominator also cos x by 2 by cos x by 2. That is 1 minus sin x by 2 by cos x by 2 will become tan x by 2. Okay, 1 minus 1 plus tan x by 2 by 1 minus tan x by 2. Okay, now I am writing this 1 as tan pi by 4. Is that correct? Because the value of tan pi by 4 is 1, right? So this one, I can rewrite this one as tan inverse of, I'll write in a different page. This can be written as tan inverse of tan pi by 4 plus tan x by 2, and the denominator one I'm placing it like that itself. Then 1 minus, I am multiplying this tan x by 2 with tan pi by 4. Is that right? Is there any change that has occurred? No, because we can write this tan x by 2 as tan x by 2 into 1, right? Tan x by 2 into 1. This 1 can be written as tan pi by 4, right? 1 can be written as tan pi by 4. We are making this adjustment in order to convert this into an familiar identity that we have studied. Okay, so this one we have studied tan x plus tan y divided by 1 minus tan x into tan y. We have studied this identity. What is this? This is equal to tan of x plus y. This is equal to tan of x plus y. All right, here in place of x it is pi by 4, and in place of y it is x by 2. So this can be written as tan inverse of tan of pi by 4 plus x by 2, pi by 4 plus x by 2. Again, if you apply the identity tan inverse of tan x equal to x, here in place of x it is pi by 4 plus x by 2. So the answer will be pi by 4 plus x by 2. The answer is pi by 4 plus x by 2. All right. Now we are moving on to the third question. Write the simplest form of, write the simplest form of, the simplest form of tan inverse of root of 1 plus x square minus 1 by x, where x is not equal to 0. X cannot be equal to 0 because if x is 0, then this function is not defined, right? So write the simplest form of tan inverse of root of 1 plus x square minus 1 by x. We have to find out the simplest form. For that, we have to make some kind of substitution, right? So here I am going to take x equal to tan theta. Okay. So from this, you get theta is equal to tan inverse x. Theta is equal to tan inverse x. All right. So tan inverse of root of 1 plus x square. X is tan theta. So x square is tan square theta. Tan square theta minus 1 by tan theta. 1 plus tan square theta is sec square theta. It is sec square theta. So this will become tan inverse of root of sec square theta minus 1 by tan theta. Okay, so that is equal to tan inverse of root sec square theta is sec theta. Sec theta minus 1 by tan theta. Sec theta minus 1 by tan theta. So, I am going to write the sec theta as 1 by cos theta. Is that right? Because the reciprocal of sec theta is cos theta, right? So, I can write sec theta as 1 by cos theta. Then there was a minus 1. Then tan theta, isn't it? Tan theta, we can rewrite it as sin theta by cos theta. All right. Now simplify this one. Tan inverse of. By cross multiplying, you will get it as 1 minus cos theta divided by cos theta and sin theta by cos theta. Okay. So, if I cancel these cos theta and cos theta, it will be tan inverse of 1 minus cos theta by sine theta. It is 1 minus cos theta by sine theta, isn't it? So this can be written as 1 minus cos theta, cos 2 theta, we know it is 2 sine square theta, which means 1 minus cos theta is 2 sine square theta by 2. Okay. And what about the sine theta? Sine 2 theta can be written as 2 sine theta cos theta. So what about sine theta? Sine theta is 2 sine theta by 2 cos theta by 2. Okay, now we are going to apply these identities in the equation. So this will become tan inverse of 1 minus cos theta. I am going to write this one as 2 sine square theta by 2 divided by 2 sine theta by 2 cos theta by 2. Okay, and we can cancel this. We can cancel this 2 sine theta. 2 and 2 gets cancelled. Then 1 sine theta by 2 can be cancelled with the sine theta by 2 of the denominator. Okay, so what is remaining here? What is remaining? In the numerator, you can see that it is tan inverse of sine theta by 2, right? Sine theta by 2 was get cancelled with the denominator, and the remaining is sine theta by 2 divided by, and in the numerator that there is a cos theta by 2, isn't it? So this is equal to tan inverse of, what is sine by cos? It is tan. So that is equal to tan inverse of tan theta by 2. So if we apply the property tan inverse of tan x equal to x, here you get it as theta by 2. And what was theta? Theta is tan inverse x, right? Tan inverse x by 2. Okay, or 1 by 2 or 1 by 2 tan inverse. You can rearrange it in any manner that is asked in the question. Okay, so this is the simplest form of our question, that is 1 by 2 tan inverse x. Okay, now we are moving on to the fourth question. This is a very important question of this session, that is prove that cos inverse of 4 by 5 plus cos inverse of 12 by 13 equal to cos inverse of 33 by 65. Okay, so these type of questions, I'm sure that you'll sometimes you'll definitely get this type of question for 3-mark question. So it is very important. Here it is given in cos inverse. So in these type of questions, you must know certain identity. That is, some of the identities, I'll write it here. In this question, we are going to apply the identity cos of x plus y equal to cos x cos y minus sin x sin y. Okay. So in certain question, you can see that here it will be a tan inverse. In some questions, in the right side, it will be sine inverse. So you should know the identities connecting these tan and sine, etc. Okay, so the identity connecting that will be useful to solve these type of questions. For the function cos is this: cos of x plus y is equal to cos x cos y minus sin x sin y. Similarly, you have to know sine of x plus y. What is sine of x plus y? That is equal to sin x cos y plus cos x sin y. Okay. Okay, if sine function comes here, you must use this identity. The methods are all same, but the identities might be different. So you should know certain identities to solve this problem, and you should practice more this type of questions. All right. So, and one more thing, that is tan of x plus y also, that we have already discussed. That is nothing but tan x plus tan y, tan x plus tan y by 1 minus tan x tan y, 1 minus tan x tan y. All right, here for this question, we are going to use this identity. Okay, so I'm taking this cos inverse of 4 by 5 as x. So what can you say about the value 4 by 5? It is nothing but cos x. Similarly, let cos inverse of, so this one we can do it in another step, okay? So first we will solve this one. All right. So I'm going to construct a triangle. From this, you have to find out the value of sin x. Okay, we are going to use this identity, so we need the value of sin x. So I'm going to find out the value of sin x from the given data. What is the given data? We have taken cos inverse of 4 by 5 as x. So by using the definition of inverse, we can write 4 by 5 as cos x. So we got the value of cos x, right? So this, let this angle be x degree. Okay. So cos means it is adjacent side by hypotenuse, right? Cos means adjacent side by hypotenuse. So which means the adjacent side of angle x is 4 and the hypotenuse is 5. We got it from the given data. So what about this side? What about this side? How will you find out? We use the Pythagoras theorem. So root of 5 square minus 4 square, that is equal to root of 25 minus 16. Isn't it? So that is equal to root 9. So that is equal to 3. So these are Pythagorean triplets. So one is 4 and 5, the other will be 3. Okay. So 3, 4, 5. All right. So we have got the opposite side of the angle x. Now, can we find out what is sin x? Definitely. Sin x means it is opposite by hypotenuse. And what is opposite? It is 3. Opposite is 3. And what is hypotenuse? 3 by 5. So we have got the value of sin x. Now, consider this portion. Okay, consider that portion. That is, put cos inverse of 12 by 13 as y. Cos inverse of 12 by 13 as y. Okay, again, construct a triangle. Let this be x. Now, from this, you will get 12 by 13 is equal to cos y. By the definition, you will get that 12 by 13 is equal to cos, right? So, this be y. We are talking the angle y. So, that is not x. It is y. So here you have got that cos phi is 12 by 30, which means this is the adjacent side and this one is the hypotenuse. So adjacent side of angle y is 12 and hypotenuse is 13. Hypotenuse is 13. So what about this side? How will you find that side? By using Pythagoras theorem. That is 13 square hypotenuse square minus base square. That is equal to root of 169 minus 144. That is equal to root of 25, right? 9 minus 4, 5. 6 minus 4 is 2. 25. That is equal to 5. So this value is 5. Okay, we have got the opposite side of angle y as 5. Now, can you say the value of sin y? Sin y is nothing but opposite by hypotenuse. And what is opposite side? Opposite side is 5. And what is hypotenuse? It is 13. 5 by 13. Now, we have got the value of cos y, sin y. Similarly, in the last part, we have got the value of cos x as well as sin x. Now, we can use the identity cos of x plus y. Okay, we are going to use that identity. That is, we have given this one as y. Okay, this one we put it as x and this one we have substituted it as y, which means we are actually finding out x plus y, right? This one is x and this one is y, which means we are finding out x plus y. So actually we are finding out x plus y, right? So we have, just a minute. And now what I'm going to do is that I'm going to find out cos of x plus y. All right. I'm going to find out cos of x plus y. What is cos of x plus y? We know it is cos x cos y minus sin x sin y. Okay. So x plus y means, so cos of x plus y equal to cos x cos y minus sin x sin y. Okay. So we have got the value of cos x, right? cos x is 4 by 5 and cos y was 12 by 13 minus sin x was 3 by 5 and sin y was 5 by 13. All right. So, here you can see that both are 5 into 13. So we can take it as common 5 into 13. So 4 into 12 is 48 minus 3 into 5 is 15. So 48 minus 15 is 8 minus 5 is 3 and 4 minus 1 is also 3. So 33 by 65. So cos of x plus y is 33 by 65. So what is x plus y? From the definition of inverse, we can write this one as cos inverse of 33 by 65. And what is this x and y? We have substituted x as cos inverse of 4 by 5. And what was y? Y was cos inverse of 12 by 13. Cos inverse of 12 by 13. That is equal to, we have now got it as cos inverse of 33 by 65. Cos inverse of 33 by 65, that is equal to our RHS, isn't it? So we have proved LHS is equal to RHS. Okay, so these type of questions are very important. You have to do different type of questions in the same pattern. Okay, with sine inverse and tan inverse, etc. All right, so we are moving on to the last question of the session. Prove that cot inverse of root of 1 plus sin x plus root of 1 minus sin x divided by root of 1 plus sin x minus root of 1 minus sin x. That is equal to x by 2. We have given the condition that x belongs to 0 pi by 4. All right, so we have to prove this one. Okay, again, we have to apply certain identities. Okay, that is, we have to make certain arrangements to adjustments in order to reach the value x by 2. So here again, I'm considering, first of all, you consider the part 1 plus sin x. This 1 plus sin x, I'm going to write as 1 as cos square x by 2 plus sin square x by 2. Okay, plus the sin x can be written as, we know, sin 2 theta is 2 sin theta cos theta, isn't it? So these are all the identities that we have already used. But again, if sin 2 theta is 2 sin theta cos theta, okay, which means what is sin theta? That is 2 sin theta by 2 cos theta by 2, right? Make half angle, right? So this can be written as, the sine x can be written as, what is the half of x, angle x? It is x by 2, right? So this can be written as 2 sine x by 2 cos x by 2. 2 sine x by 2 cos x by 2. And what about 1 minus sine x? So this means, this is of the form a square plus b square plus 2ab. So this means it is a plus b the whole square, right? And what is a? A is cos x by 2. And what is b? B is sin x by 2. So a plus b the whole square form. Alright. Now consider 1 minus sin x. Similarly, you can write this 1 as cos square x by 2. 1 as cos square x by 2 plus sin square x by 2. And there is a minus, and the sin x can again be written as like this. That is 2 sin x by 2 cos x by 2. So this you can see that it is of the form a square plus b square minus 2ab, right? So this can be written as a minus b the whole square. And what is a here? A is cos x by 2. And what is b here? B is sin x by 2. So cos x by 2 minus sin x by 2 the whole square. Okay. Now what we are going to do is that we are going to substitute these values in our question. All right. So that is cot inverse of root of 1 plus sin x, right, plus root of 1 minus sin x divided by root of 1 plus sin x minus root of 1 minus sin x. All right. So this can be written as cot inverse of root of 1 plus sin x. We have found out the value of 1 plus sin x. It was cos x by 2 plus sin x by 2 the whole square. Right. plus root of 1 minus sin x can be written as cos x by 2 minus sin x by 2 the whole square. Similarly, in the denominator also you can make such substitutions. Okay, it will be sin x by 2 the whole square minus root of 1 minus x can be written as cos x by 2 minus sin x by 2 the whole square. Alright, now cot inverse of what is this cos x by 2 plus sin x by 2 the whole square. The root of that value is cos x by 2, cos x by 2 plus sin x by 2. And what is the root of this one? Root of this one is nothing but cos x by 2 minus sin x by 2. Similarly, in the denominator, you can write this one as cos x by 2 plus sin x by 2 minus of cos x by 2 minus sin x by 2. Okay, so in the next step, if I take this minus inside, okay, in the denominator, I'm going to take this minus inside. So minus of cos x by 2 is minus cos x by 2, and minus of minus sin x by 2 will become plus sin x by 2. So I've taken the minus to the bracket, inside the bracket. Okay, so if I cancel this cos, can I cancel sin x by 2 and sin x by 2? In the denominator, which value can I cancel? I can cancel this cos x by 2 and minus cos x by 2. So what is the value? Remaining value is cot inverse of 2 sin, in the numerator it is 2 cos x by 2, and the denominator it is 2 sin x by 2. Isn't it? And we can cancel this also. This 2 and 2 can be cancelled. So this will become cot inverse of cos x by 2 by sin x by 2. Cos x by 2 by sin x by 2. So that is equal to cot inverse of cos by sin is cot x by 2. Cot x by 2. Right? So that is equal to x by 2. This was our RHS. Right? This was our RHS of the question. So we have proved LHS equal to RHS. Okay. So these are the important type of questions that are asked in the 3-mark session. And in this session, the most important question that I can say is that the question that we did earlier before this question. So this question is very important. This you should practice with more type of questions in this. Okay. So I hope this session was useful to you all. So from this session, we have finished the chapter inverse trigonometric function. In the next session, we'll be continuing the chapter matrices. All right. So thank you.